Hi, hi, hi. Drop your name in the chat when you join. Drop your name in the chat. I see we have someone inside. Drop your name in the chat. Welcome, welcome, welcome. Drop your name in the chat when you join and let's get to work. Let's enjoy, let's enjoy. Drop your name in the chat. Okay, we're about to get started. Just give us a few minutes. Just give me a few minutes to allow everybody to join and we start. We're gonna have fun, all right? We're gonna have fun. This is gonna be really, really fun. I hope you're ready. Drop your name in the chat. Drop your name in the chat when you join us. Drop your name in the chat when you join in. When you join in, let's get ready to ace. Share into every A-level group. Share everywhere. Let's have fun. Let me just do this. Give me 1 second. Give me 1 second. Okay. Think we're ready to start. Let's enjoy. Let's have fun. Uh, one, two. Let me just make sure that you can hear me. Sorry for the glitch. All right. I think we're cool now. Okay. So let's get to work. Let's start. Like I said that we're going to be going through okay, here's a paper, but what I want you to do is not just to solve this paper. What I want us to do is I want us to analyze this paper together. But we're going to be doing. Let's make sure we enjoy it. This is going to be fun. Let me make. Oh my goodness. Uh, okay, so I think you're good. If you have a problem, you tell me. Okay? If you have a problem, you're going to tell me. So here's the thing. Let's go to the complex numbers. Okay. And they're giving us that whatever. Then they're saying state the value of omega z1 and omega z2, which you're going to do nice and easy here. But here's the thing. First of all, what I want you to do is, first of all, I want us to like talk about complex numbers and what they are, then come to answer all these questions, and we must be able to do them in no time. Okay, without having to stop. We don't want to have to do one question at a time and things like that. So let's see how it goes. Um, let me show you something. I deliberately put the book so that I can show you how this thing is asked. Look at this. Okay, it's not here, it's here. Okay, if you can still hear me, please make sure you're putting comments, so that I'm sure you guys can hear me. Open the panel for live chat if you want to be. Yes, good. So here's the thing. Look at this. I'm going to go to the course book for paper 3. Then I'll quickly take you through this. I want you to see this because I don't want to be saying when you can't hear me. I just want you to see what I'll be talking about. And then I'm going to go and write it down separately, and we're going to answer these questions. So remember, we are analyzing topic by topic. We want to do this paper. We want to do these papers nice and easy, fast. We have to get the marks. Paper 3, we have to get the marks, guys. Look at this. Okay, here it is. Look at how it works. First of all, I want you to see the topics, the things that are talked about in here in complex numbers. I'll be just highlighting the important things, important details, and we'll be moving on real quick. So here's your complex numbers. If you see, it is divided into 5, right? So first of all is us looking at complex numbers. And then the last thing, which is 11.5, is going to be how we are going to do loci. Loci is drawing, and we'll be dealing with points around. We'll be dealing with a distance around a point. We'll be dealing like things like a circle and whatever, and we'll be trying to calculate distances using complex numbers. Okay, so here's this thing. First of all, I want us to quickly look at this and master this. Guys, look at this. This is complex numbers. I want you to have an idea of complex numbers from the book, of what is going on. I want to quickly show you. Then we're going to analyze the questions from past papers and see how they ask. So here it is. Here is what complex numbers is. We should finish this topic in no time and do all these questions. So first of all, it explains to you. Let me just tell you. It's trying to explain to you in this first page in 11.1 what imaginary numbers are, because what we call a complex number is a number that has 2 parts. A number that is imaginary number is not a complex number. A complex number is a number that has 2 parts. It is a number that has a real part and an imaginary part. That is what we'll be calling a complex number. And you see us represented by the letter Z. So here they are just trying to teach you what an imaginary number. Imaginary number is a number you get when you do square root of a negative number. When you do square root of a negative number, you get you have a number which is called imaginary. You can't punch it in the calculator and get an answer. Impossible. So this number is called a complex number. And how we are going to solve it is we are going to introduce a guy called I. Okay, and we're going to be able to solve this to get this imaginary number. But that's not the complex number. The complex number has an imaginary part and a real part. So here, ignore this first part. Okay, I've already explained to you. Here's just what it is. We don't want to waste time. We don't have time to waste. We do not have time to waste. We want to look at the hard things. We want to be able to quickly solve. Let me try to open the book real quick and show you what is going on here. My goodness, where's the book? Where's the book? Where's the book? I'm trying to find the note writing software here. Sorry. I'm not locating it. Okay, here it is. Right. So here's what a complex number is. We have a complex number z. We say z is equal to a plus bi. This is going to be our complex number, right? And what is it? It is a number that has a real number, which is a number itself. So this is the real part, which we call re, okay? Then here, this is now the imaginary part, okay? Imaginary part, which we call im, okay? So this is called im, which is, this is the imaginary, and we call this im. This whole number here, this whole part. Now, we represent, you can locate it by having this I, and I squared, we say that I squared is equal to -1. When you have an I squared, it represents -1, right? So when we now say I is, what is I? It is just going to be the square root of -1. So we are able to remove root -1 by putting an I. If you put an I, you are going to remove root -1 and put I, because root of a negative we don't have. So let's say I have root of -4. I'm going to make this root of -1 times 4, because that's -4, which is going to be root of -1 times root of 4. You are allowed to separate. When things are multiplying or when things are dividing, you can separate. Then root of -1 is your I. So we'll have I root 4, which we can write as root 4i. This is another way of writing. And now we have our imaginary number. Why did we get it? So that we put it in the complex number. So we are not going to dwell on that part for a long time. We move on. We understand what an imaginary number is. We just get it when we have square root of a negative number, and it's going to come out as this with an I. That's how it's going to come out, right? Then we move on to the next thing. So thank you for that. Now we have seen what a complex number is. A complex number is represented by z. So what have you learned so far? That a complex number is something represented by z. And z is my complex number. It has two parts, right? It is a number that will be having two parts, and we represent it using the letter z. It has a real part and an imaginary part, and we understand what an imaginary part. Now let's go back to the book, because I want to skip things. I want to move real quick here. Let's go back to this book. Here's the z. Here's the book. Oh my goodness, what happened here, man? Okay, let me open it again. Sorry for that small glitch. All right, so here it is. We're looking at our pure mathematics 3, right? We're analyzing our stuff. We're analyzing. Here we're going through the topics as well. So now we are going to, you see 11.2 there, it started to explain to us what complex numbers are, which is what we are looking at. We don't want to waste time. So here's your 11.2. Let's be fast. Let's just quickly go through it. And we want to see the questions. We don't want to look here. So we see that a complex number is represented by z. And there are many ways of writing it. Here's another way. Z is equal to x plus iy. Okay? Or a plus ib. Or whatever. You can see here they're representing. It's just something. Or you can have here, they're showing you. Let me try to write on the screen. Let me write on the screen. Give me a sec. Okay, so here's what I was saying. Here we have the z is x plus iy. Then here we also have z is x minus iy. These are just numbers, right? So these are just numbers. Like to say z is going to be equal to 4 plus 5i. We'll be having a complex number. Why is it complex? Because it has a real part and an imaginary part. That's our complex number. Now, why are we learning about this? Why are we learning about this guy? That's the question. Because that's the real question. What are the types of questions they're going to give us? Why are we learning about these complex numbers? What is it that he can solve? Okay, so we have it's represented as that, right? Let's see how let's see why we have learned about him. I want you to start to see the things. Okay, I'm trying to open. I hope it can still open. Oh. Right. It's loading, it's loading, it's loading. So there are the things I can teach you whilst you're not seeing. Wow, my tech is really fighting me. Big time. Wow. Let's see how long I can go. Uh, okay. I think you can both hear me again and see the screen. Thank you for your patience. Sorry for that glitch as well. Let me be fast. So I was saying that I know you didn't hear me when I say, but I was saying on this page now you're being taught to do four things. You have been taught about complex numbers, what it is. Then they give you examples of two complex numbers, Z1 and Z2. Those two complex numbers they give you as examples. Then they start to show you how they add them, because you need to know now. You know what a complex number is. Now you need to know, how do I add two complex numbers? How do I subtract two complex numbers? How do I multiply two complex numbers, Z1 and Z2? How do I divide? So there is addition, there is subtraction, there is multiplication, there is division. Guys, we study smart, we move on. 1, 2. One, two. Okay, I'm back. The hard way. Whew. Yeah, this is a lot. Either way, let me see. I'm going to try. I think I would have passed on the audio mixer. I think I would have passed the limit of decibels when I was shouting. So I'm going to try and reduce the volume to make sure that I don't do anything that is going to take us off to reduce to remove the audio. So now, what was I saying? I'm going to be shouting again. So I need to make sure that I don't pass. Okay, so here I'm watching myself from here now to make sure that I don't, but I'm still gonna be shouting. I have to. My back. If you look at I was saying, guys, listen, and watch this. For complex numbers, this is how easy it is. Um, if you look at this whole thing, this thing which I've shown you. The next three things that come, it's chapter 11, right? 11.2 was when you were introduced to complex numbers, right? 11.2, you were introduced to complex numbers and you were taught, or we are going to go through it again, but I want you to have a picture of this thing. And when you're seeing me solve questions and explaining, it will make sense. Look, 11.2 was just introduction to complex numbers. So you were introduced, okay, what are complex numbers? Blah, 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 blah. Complex numbers are represented by Z. Z is going to be what represents. So you're going to say Z is equal to, then you put your complex number, right? Now, what is going to happen is, it has two parts, right? That complex number Z will be having two parts. A real number. Okay, I'm back. Wow, this is going to be a long one. I don't know. I'm going to try and see the tech guy and see if I can be able to fix this. Here's the thing. After you know complex numbers, then you do three things. So let me just tell you now. There are three things, guys. Number one is Argand diagram, which is the complex plane. So you're going to be asked, do this, do this. It is how you put a complex diagram on you represent a complex number. We call it the complex plane, right? It has, instead of the x and y axis, it has the real axis and the imaginary axis. Imaginary is y, okay? Imaginary is the y, the real is the x. Let's go and see. Then 11.4, I'm giving you a prelude. 11.4 is now, how do we solve equations using complex numbers? That's going to be tricky. But I'm going to need you to really watch closely on certain steps that if you remember, you'll be able to solve, right? Then the third and the final thing. So what type of questions do you get in complex numbers? 3. One is representing them on a diagram. Then 2 is solving equations using complex numbers, finding roots, right? Then 3 is loci, where we are going to be drawing circles. We're going to be drawing circles using complex numbers. So those 3 are the types of questions. No other type of question is those 3. It's going to be revolving around those 3 things. So let's start with this Argand diagram. That's the first type of question we are going to get. Really? Yes. What is an Argand diagram? It is what we use to represent a complex number. Remember, we said a complex number is a number that has 2 parts. It is a number that is a real number, which is a normal number, and an imaginary number, which is a number with I. And we know what I is. I is square root of -1. Why did we bring it? So that we are able to solve a square root of a negative number. So here we now have, okay, let's say that I now have a complex number. I've been given one already, and they want me to put it on a diagram. How do I do it? Remember your Argand diagram, that the y-axis is the imaginary, which is the thing with I, the number with I. But when you are putting it, you don't put the I. Okay, the fact that it had I means it was the imaginary number. But when you are now putting it on the imaginary axis, you are just going to put the number itself, the number that is in front of I, sorry. Then you're going to have a real number. For the real number, you're going to put the number which is the normal number, the number that stands alone. So you're going to, I'm unable to write on this screen. I'm sorry, I should have been writing on this screen to show you what I want you to see. But I'm not really able to. I'm going to show you after I make you just see from the book, okay? So here is our imaginary plane. We are taught to represent it, and we're going to represent points, and we're going to be drawing things. Okay, so now what will I use this? Let's say that I have seen the Argand diagram. I'm able to represent, right? I'm able to represent a number on an diagram. Now, what else will I be made to do? Here's what I want you to see, guys. You can be able to have a complex number. I'm trying to show you an example, okay? You can be able to have a complex number, and this complex number, instead of representing it as x plus iy, you can represent your complex number. Remember, let me go and show you. I don't want you to think this is hard, because it's not. It's not hard. I'm going to show you. People who have done polar coordinates might remember this. Look at what is going on. Here is our Argand diagram. We've just been seeing that there's something called an Argand diagram. Remember, you have a complex number. A complex number is a number with 2 parts. A real part and an imaginary part. 3 plus 4i. This is a complex number. You are going to see what we use it for. Mathematicians are not mad people. I know they look like mad people, but they are not. And I'm going to these things which you are learning are practical in real life. You would have no electricity without them. Okay, you would have no electricity without them. That is how they design things at the power stations there. So this is important. Our complex number here, we remember it's going to have imaginary axis, which we say imaginary of z, because z is your complex number, right? Then you're going to have the real, which is going to be the real axis, real of z. And remember, the x-axis is the real axis. So let's say I want to represent this complex number code 3 plus 4i. Okay, I want to represent this 3 plus 4i. It is going to be what? 3 is the real, because it's the normal number. It's the real number. Then this is the imaginary number. We have the real and the imaginary. So what am I going to put on the real axis? I'm going to go to 3. So I go to 3 on the x-axis. Then I go to what on the imaginary? On the imaginary, I'm going to 4. So where 3 and 4 meet is going to be where I have my point here. I have my point at this point called 3, 4. Now, this is how I can locate this point. I can call it point P or whatever. Now, is that the only way? Is that the only way to be able to locate point P from the origin? No. there is another way to come from origin to go to point P. And it is by doing this way which I'm showing you, which is to find this straight path from origin to point P, which I'm putting in green. And we call it the argument. Okay? We call it the modulus, sorry. When we are representing this, right? We're going to have two things. We're going to have the modulus, and we are going to have the argument, which is going to be theta. So if I have modulus of z and I have the argument of z, then I can be able to find what? I can be able to come from the origin to go to point P as well. I need to know the length of this straight from origin to point P, and you tell me what angle to move at. So you can either tell me, if you want me to go to point P, you can say move 3 steps on the real axis and then 4 steps on the imaginary. I will arrive. Or you can say go z steps from the origin straight to point P. Okay, I can go, but tell me what angle. Because if I don't obey that angle, I'll miss point P. So you're going to say, move exactly 5 meters. And your 5 steps should be at an angle of 30 degrees from the real. Then I'm going to arrive. So that's the other notation which we're going to be using. Okay? We're going to be using that notation. You hear me? Good. We're going to be using that notation to do what? To still represent a complex number. That is what they are now showing you again in the book. Another way to represent a complex number. What are we trying to do? We'll be just trying to come from the origin to go to a certain point. So that one is it's not a complicated thing. So we are learning of the Argand diagram, and we have seen that the Argand diagram is real and imaginary. And we can plot it that way. Or we can also say, when on my Argand diagram, I can also have what? I can also find the modulus, and I can also find the argument. When I find them, I can still do what? I can go to point P. Is that hard? I don't think it is. I don't think it is. Okay, that's another one. Now let's try and solve. Let's go ahead and let's see what the book was telling us about. Okay, so how to get this? One. Okay. Okay. Oh. One, two, one, two, one, two, one. Okay. What I was saying is, generally speaking, we just represent. This is the notation they'll give you to represent a complex number, x plus iy. But remember, when you put, actually the number comes before I. Anyway, this is what you have, right? Now, if I have these two, how do I get modulus? You just square the real and then you square the imaginary, leaving the I. Okay. If you want to get a, this is what you'll be doing. You'd be saying, okay, I would say, let me put it again. Even if I put with my I, this is going to be what? Let me put it and take you. Oh. It's going to be like this. Let me put it. My pen is not responding. Give me one sec. Give me one sec. Let me fix my pen. back. So what was I saying? I was saying what you do it is when you're representing the modulus, remember to ignore the I. Just take the number and then you put. But when you take the number, take it with its sign. If it's a negative number, take it with its sign, and you're going to be correct. Then you're going to get your modulus of z. They can call it r. They call it r, which is the modulus of z, and then you have theta. So you now represent your complex number, saying what? Theta, how do you get it? Theta is just tan inverse of y over x, which is tan inverse of y, the imaginary, over x, the real. That's always how you get tan theta. It's always y over x. Okay? So here is what you're going to do. Then when you have r and theta, you say that here you now have the modulus. Then when you have theta, you now have the what? The argument. We call it arg z. That's the argument. If you're asked to find the argument, it's just tan inverse. It's just tan inverse, guys. That's all. That's how easy it is. And now when you have it, how are you going to write it? So let's say I now have r and theta. How do I now write my new complex number? This is how you now write it. Remember, you have found z, isn't it? Then let's say you have found r. The r is the modulus, right? We call it r is what we call the modulus of z. Then we have theta, which we said it is tan inverse of y over x. We have it. So now I have r, my modulus, I have theta, my argument. How do I now write my complex number? I'll now say z is equal to, then what do I put out? I say r, then inside the brackets I'll say cos theta plus I sine theta. So it will be, z will be, you put your r that you would have found, then inside your brackets you put cos theta, which you would have found again, plus I sine theta, which you have found again. And you now have represented it in trig form. And we'll see what we're going to use this for. But this is the other thing which you are being taught. If you now know how to do this one, that'll be good. That'll be good. So this is going to be the notation. Now, one more notation. So here we can say that, first of all, we were talking about complex numbers. And we saw that it's represented by z, and it has two parts. Real part, just a normal number, plus imaginary part, which is an I. And we say that we saw that sometimes we may represent it as here, as r, then you put cos theta plus I sine theta. And then you can also put it as z is going to be equal to, with r and theta again, r, then you now say e to the I theta. This is now, these are the three ways of writing complex numbers. Okay? This is what we call the Cartesian way, or this one is going to be called the Polar way or trig way. Then this one is going to be called the exponential way of writing. This is the exponential form. Now you say to me, okay, what is the benefit of you learning how to do? Testing the mic. Okay, it's working. So far, so good. Happy days are back. So what I was saying was, we have these three forms. Why do I need to learn this form? I'm going to show you. You learn this form because, yes, it's very quick when you now want to multiply. You have two numbers, z1 and you have z2, right? If you write them in exponential form, right? If you have them in exponential form, and remember to put exponential form, you just need r, the modulus, square root of that, and you need theta, which is tan inverse of y over x. You get r and theta, you can put in the trig form or the exponential form, right? So that's important. Now, when you have it in this exponential form, let's say you have z1 being r1, which you're going to get that r1, then you say e to the I theta 1. Then remember, it's r e to the I theta. Okay, theta 1. Then you now have Z2, which is going to be R2 e to the I theta 2. You have these two, right? Now, when I have these two, I can be able to find Z1 times Z2 fast and easy. And I can be able to find Z1 over Z2 easy as well. Really? Yes. How do I find Z1 times Z2? To find Z1 times Z2, it is just going to be equal to, remember, you'll be saying I'm multiplying R1 e to the I theta 1 times R2 e to the I theta 2. Remember, it's R e to the I theta, which is going to be, when you now want to get an answer, you're just going to say R1 times R2. Then you now say e to the I theta 1 plus theta 2. That's how you're going to get an answer. Okay? And then for this one, when they are dividing, it will be again R1 over R2. Then, because you're saying it will be R1 e to the I theta 1 divided by R2 e to the I theta 2, which is going to be, it's just going to be R1 over R2, like here it was R1 times R2, but then it will be now e to the I, then you say theta 1 minus theta 2. That's what happens when you are dividing. Theta 1 minus theta 2. And you'd be done. That's how you're going to do it. Okay? That's how you're going to do it. Isn't it easy? Isn't it easy? Okay, so we're going to be, it's going to make it very, very easy for us when we're 1, 2, 1, 2. All right, stay here. This is going to be what you need to know. You're done with the complex plane. Remember Argand diagrams. Argand diagrams, you need to remember this form. Okay. I promise when we have a break, I'm going to resolve this audio issue. I'm going to find out what is going on and then put something which is going to be permanent for us. We don't have to have audio come and go and come and go. But anyway, that is it for the complex plane. We have seen some things and it's going to make our work much easier. So we'll be having an Argand diagram which we can represent not in this form really, but we represent when we have a complex number in this table form, in the table form or the Cartesian form. Then we are going to be able to change it from that to the trig form, and then we can change it to the exponential form. You can just remember that to say if I have z being equal to x plus iy, then if I want to now have it is z being equal to r e. Let's start with r. Let's start with the trig form. We say r, then what? Cos theta plus I sine theta. Don't forget. Then we have z is equal to r e to the I theta. Now, how do I get, for these two, I'm going to need r and theta. Right? And z, and to get my r, we can say that r is just equal to the modulus of z, which is the square root of x squared plus y squared. Then we can say that theta is tan inverse of y over x. And we are going to have our solution. Then would be good. Okay, you hear me? That'll be enough. We're just going to represent in that form. If you're able to do that, then wow, everything will become very easy. And we're going to enjoy. Now remember that when you're doing the theta, it should be in rad. It should be in radians. Should have an answer in rad. We don't want an answer in degrees. Remember that. Okay? Good. Your answer should be in rad. And I'll show you where finding this theta can be tricky. We're going to need to know let's just say, be careful here. Make sure your calculator is in rad when you're calculating this theta. Okay? Make sure, and you're going to get whether it's 0.93, 0. Whatever, negative 2.47, whatever radians. That's fine. But make sure your calculator is in rad. This section is done. So the section for complex plane. Have you seen it? Say yes if you've seen it. Say yes in the live. Put something in the chat. I like it. So here we'll be having the first part done. All right. Next point. Let's do the next point now. Next point is going to be the second thing. What do we do with complex numbers? Because I want you to know all the types of questions that complex numbers will give you. One is question to do with the Argand diagram. We have questions to do with the Argand diagram. Okay, fine. I have questions to do with the Argand diagram. What else do I have? The other thing is going to be now, I'm erasing this. The other thing is now going to be to do with solving equations. Let me go and show you at the book. Then we come back and we do it in person. Remember that the book has shown you that you have 3 things to know. Do not forget that. Only 3. 1, 2. Only 3 things to know. All right. Last thing. Last 2 things. Last 2 things, guys. The last 2 things here. 11.4 and 11.5. This is carrying the whole complex numbers. Everything is in here. Let's see solving equations. What happens? Okay? If we know this, we mustn't panic when we get a solution. So, here's the thing, guys. We want to find solutions. And we are going to have different types of equations. You're going to have a quadratic equation. You're going to have a cubic equation. You're going to have a quartic equation. Where is it? And I want to show you what we're going to use. So here's the idea. Remember this statement. Remember this statement. The statement is that when you are looking for roots, complex can only have even numbers of roots. Remember, if an equation is a cubic equation, it has 3 solutions. if an equation is a quadratic equation, in other words, it's x to the power 4, then for you to say you are done with that, you need to have 4 solutions, right? A quadratic equation has 2 solutions. So here's the thing. You can, when you are finding solutions, right? You are finding, remember, a complex number is a number that has 2 parts. It's going to be a number with 2 parts, guys. So it's going to be a number with an imaginary part and a real part and an imaginary part. One, two, 1, 2. One. Okay, so I was saying we're going to be looking for answers. And when you get answers, one of your answers could be a complex number. One of your roots, solutions, when you solve the equation. Now, when you're getting it, just remember this root so that you understand the methods we're going to be using. One, two. 1, 2. All right. I hope it doesn't cause me problems. Come on. So here's the statement to remember, is that complex roots can either be 2 or 4 or 0. You can't have 1 complex answer. You can't have 3 complex answers. You can't. Okay? You can't. So let's talk about it. I don't want you to see this page. I want us to discuss together first. If we are saying, what did we say? How many complex roots can you have? Can you have 3 complex roots? No. Can you have 4 complex roots? No. Can you have, can you have 5 complex roots? No. It can only be even numbers, 0 or 2 or 4. So can I have 4 complex roots? Yes. Can I have 2 complex roots? Yes. Yes. So if I have a cubic equation, tell me what are the situations I can have there. If you have a cubic equation and you are solving it, either you can have 3 solutions that are real, okay, that are normal only, or you are going to have, on your 3 solutions, you're going to have 2 of them being complex solutions and 1 being just a real solution. For quadratic, what are the situations I can have? I can either have 2 solutions being complex and 2 being real, or I will have all 4 being complex, because complex can be 4. So for cubic, there can be 3. So either we're going to have 2 complex solutions and 1 being a real solution, a normal number. Or we're going to have on quadratic, when we're solving quadratic, we know that I should have either 2 complex solutions or I should have 4 complex solutions. That should happen. Okay? So now let's solve this. If I get a cubic equation, I have that in my mind, that the solutions here, if I have complex solutions, because we're in complex numbers, so the complex solutions are going to be there. They are going to be there. But when I'm solving, I know that I have 2 complex solutions, because this is a cubic equation. I will have 2 complex solutions, then 1 will be real. Okay, I have 2 complex solutions and 1 is real. I know that. For my cubic equation, I know that. Remember, this is just one of the 3 things you're going to have to do with complex numbers. One was the Argand diagram, which we have been seeing. The second is now these equations, solving equations using the idea of complex numbers. These equations, when we were in IG and other levels, we had equations that we said have no solution. Even at AS, we said they have no real solutions, and we left it there. But now we are no longer doing that. If we get something, we will say it has complex solutions. And the complex solutions could be 2 or could be 4. You hear me? So here is a cubic. If I get a cubic, I know, because I'm in complex numbers, that's the topic. I'm going to have complex solutions. And how many are they going to be? 2. Then the third is going to be a real number. So what they're going to do is, for a cubic equation, they make it easy. They're going to give you one complex solution. Now, when they give you one complex solution, just know this, that the other complex solution is going to be the conjugate of that one which they have given you. And you stop there, because complex solutions should be two. So now when I have those two, now my job is to then find the third solution, which obviously is a real, because I can't have three solutions. I know for cubic I need to have three solutions, but I can't have three complex solutions. Let's see how we're going to do it. Look at a question here. 1, 2. Okay. Look at this question. Just look at this question, right? Look at what they have said. And you're going to see how they are going to quickly solve this. So, what have they said? Okay, for this one they're going to use an idea from for this one they're going to use an idea from the very first chapter, which is algebra. Um, I don't know if I want to solve this one, but yes. Okay, here we have here you have been given a root. Here you've been given a solution, and they said show that z equal to 4 is a root. Then they said find all the complex solutions. Find all the complex solutions of z cubed. Blah 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 blah. Right? All right. So what are we going to do? Well, for this one, because they gave me z equal to 4, you'll be having, for complex numbers, it's going to be the very same thing as what you do in topic 1. But instead of x, you have a z. So that's not a complicated thing. We just use it the same way we did for x, we do for z. That part is fine. Ignore this. This type of question, I don't like it. Well, I'm going to show you. This one is a little bit of an easy one. I wanted one where they give you a solution, one solution which is complex. Then you're going to use that idea right there. But anyway, for here they gave me they said z equal to 4 is a root. Remember, 4 is a real number, right? So if I know that 4 is a real number, here's the idea. You've been given an equation. Let's go. Okay, let me ignore this one. I'll come back to it. I don't want to do this simple one. I'll explain to you when we are doing it alone. It's a little bit off from the first topic. I wanted to do a different one, but let's start with this one. Let's do this quartic one. We'll come back. But the idea is just going to be on cubic. When I get my cubic questions, I know that I'm going to only have two complex solutions, and the third one being a real solution. Like this, z equal to 4. That's going to be the third one. Then the other two will be z equal to something with an I. Something plus something I. One, two, three. All right, let me just say what I wanted to say. I wanted to say that here, for cubic, remember that if they give you the solution, because I'm sure we're going to meet one where they do that, I know that. When you get the first one, say z is 4 plus 3i. The other one is going to be z is equal to 4 minus 3i. These are going to be the two. That is, just know that the two conjugates, they are conjugates. One is a plus, the other one is a minus. Are two solutions of your complex. And you'll be now needing to find the third number, which is going to be the third value, which is going to be what? An imaginary. We can always find that. So if I have these two, Then I'm going to find the other one. I'm going to multiply them together. And when I multiply them together, I'm going to get an answer. And I'm going to divide it into the original z. I'm going to divide it into the original z. Then I'll find a solution. When I find my solution, when I divide into the original z, into the original one, okay, the original one with z's and stuff, when I divide into it, by when I multiply, remember I'll multiply z1 and z2, right? And then I'm going to divide into the original one. I'll get a number which is going to be the third solution. That number which I get is going to be the third solution. In here I got a number z equal to 4 as a solution, and they wanted me to find these two complex solutions, which we know that the two complex solutions are conjugates. So if you've been told that z equal to 4 is a solution, that means that z minus 4 is a factor. So if z minus 4 is a factor, what we are going to do, we divide the original thing, blah, 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 blah. We divide it by z minus 4, okay? We do long division, obviously. So it's going to be, we divide that big thing, we divide by z minus 4. We're going to get whatever we get. And that thing which you're going to get is what we're going to factorize and get two solutions which are going to be complex. So solving equations is fine. Let's just see the last part of solving equations. We'll find questions, but I want you to see that those are the sections, okay? We'll talk about it in a question. I'm going to see a question. We love questions. We have to do questions. One, two. Okay. Let's finish this off. So when we finish with these complex solutions, we are going to have the two complex solutions and we'll be done. You can see that there'll be conjugates. Now, let's see what we then do when we have, okay, for cube roots we are done. Let's see what we have for quadratic equation. A quadratic equation, we know that it will either have two complex solutions and two real solutions, or it will have four complex solutions, because it should have four solutions. So either it will have four real solutions, or two real and two complex, or four complex, because complex can either be two or four only. So here we'll be having it, and that is what you're going to do. So what you're going to do for your equation which is quadratic, I'll show you what they're going to give it. If they give you one, what you know that if I'm always given a factor, its conjugate is also a factor, because when I have complex solutions, they're going to be two or four, and the factor, the conjugates will always be there. If you're told z minus 2i is a factor, automatically you know that z plus 2i is also a factor, because conjugates are factors together. Okay, so what we are going to do is multiply those two conjugates. We'll multiply those two conjugates, and then we'll divide by them. So we're going to divide by them, and then we're going to get something which is quadratic, which we'll solve again and get solutions. The solutions may be complex again. We'll end up having four solutions. That's not a problem. That's not a problem. But let's do this last type of question. Let's do this last type of question. We'll talk about it. I don't have a pen to be highlighting what I wanted you to see, but I have the pen, but it can't write on the screen. I'll show you, don't worry. I'll show you where I want you to see. But anyway, here is going to be the last one on this type of section, or the second from last. Almost done. This one is going to be now still under quadratic, but it will be now saying find the square root. They'll say find the square root, and then they'll give you something. So when you're finding the square root of something, you are just going to call the square root of that something, you call it a new complex number. So you're going to call it a new complex number. The square root, because you want to find the square root of that thing. So you create a new complex number called x plus iy. Then what are you going to do? You are going to make it equal to 1, 2. Now, the last thing is going to be talking about loci. This type of question I'm going to show you, where you're going to be given something and you're trying to find, they say z cubed is equal to 8, right? Z cubed is equal to 8, and you find the cube root of 8. Now, when you get this, though, what you must know is that when you're going to get this solution, you are going to be able to put it into complex numbers, because remember, when I have a cubic thing, what do I expect to have? One, two, 1, 2, 1, 2. All right, so what was I saying? I was saying, okay, what do you need now? Loci. Loci is the last thing. Loci, yes. I think this needs me after having given you a break. But just look at this. Let me just show you the sections at least. This is about us describing 3 things. First, we are going to be describing things that have a circle, things that are in a circle, points that are in a circle. We are going to be describing them using complex numbers. Circle. So we'll start with things that are in a circle. And you're going to see, how do I represent loci, right? Here, the first thing they teach you is, how do you represent things that are going to be in a circle that has radius 0, 0? Circle, when you want points that are inside. So here is what you're going to do. You're going to be saying, if you want to represent things that are in a circle, look at how we're representing it. We are going to have 2 z's. Here is your Argand diagram. You're going to have 2 z's. Now, what are the 2 z's that I'm going to have? 2 z's that you're going to have is going to be something called z and something called z1. Now, what is it that I'm going to have? What is my z and my z? Whenever I put a z on your Argand diagram, it is going to be something that is measured from the origin. So if I want to find, if I see a z, it is always going to be something measured from the origin, right? So if I come and say to you, z is less than 5, this is going to be a circle, which is going to be what? You want all the points that are inside the circle that has radius 5. If you say modular z is less than 5, modular z less than 5, if you say I want loci, now we are representing points on a diagram. If I say I want all the points where modulus of z is equal to 5, that's a circle. And these are points that are sitting on the circumference of the circle. Okay, maybe I'm going to need to explain it whilst writing. Remember, it's very hard for you to understand what I'm saying uh without me writing it down. I'm going to write it down so you can see this loci. Complex number is in 3 parts. This is the last part which you're going to be questioned on. Okay, this is going to be the last part which you're going to be questioned on. It's going to be it's going to be loci, right? What are you going to have? Here you're going to, for loci, you're going to need to know. Look, let me just show you what you need to know. Then I'm going to explain to you whilst writing on a piece of paper, because I wanted you to see from the book. So when I explain to you, it actually makes sense. What you're going to need, this is what the book teaches you, so that they will ask you about it. You're going to be asked about this. You're going to be given points that are in a circle or a semicircle or whatever. Will represent them using this idea. So you must know from this, when you leave this idea, you must be able to know how do you represent all the points that are, number 1, on a circle, number 2, in a circle, number 3, on the circumference and in the circle. So we want on the circumference only, then inside the circle. Two, 1, 2, 1, 2. All right, here they are teaching you things with center AB, right? They are teaching you to say, what will you do when you have center AB? Then the last thing is going to be, how do you now represent this idea of half lines? You're going to say to me, what is a half line? All right, when we are now talking about half line, we are just going to be joining 2 points. I want to join 2 points. I want to come from Q to go to P. So I will need to know how to represent that line from Q to go to P using complex numbers. I'm going to need to know its length, then I'm going to need to know the angle to move it. Angle with the horizontal to come from Q to go to P. If I have that part line, then I'm going to be able to answer, I should be able to answer the questions. So here is an idea. You must know what? How to represent circles. You must know what? How to represent a line that joins 2 points. You must know what? Here, the last thing, you must know how to do perpendicular bisectors using complex numbers. If I know this, am I done? Yes. This is going to be a complex number. This is going to be a complex number, my friends. What I wanted you to see was the sections. Now, what I'm going to give you is a small break, right? For your mind to break a bit. Then I'm going to come back and explain these things which I've been showing you. If you know this, that's what complex numbers are about. I need you to know what they're about, because when you get them, you must be able to solve them. This is how you know topics. This is how you should be saying, I'm good now. Not to just know one part. Oh my goodness, I didn't know that the screen is gone. One, two. Okay, my screen is gone. I will be back. Let's take a break. Goodbye. I'll come back and we'll continue this and do questions.